Hi, I'm Jeremy.
And I'm Casey.
Welcome to our farmstead, Cornucopia Orchards. So this is what the inside of my pressure pump system looks like for our septic tank. It will tell the system to turn on and start pumping once the first couple of floats hit a certain level. And then if that fails, then the third float activates this alarm box over here to scream at you. We're just running it up to 2 inches above this rim of this riser here so that we can make sure that it's not got any substantial leaks. So the septic system is going to depend on what the DEQ says you have to do. They will tell you where you can put in a septic based off of the soil composition and the expected drainage capabilities of that soil. And in our case, we have a more expensive than normal septic. So ours is not gravity flow. It only flows by gravity down to the tank, and from there it has to be pumped up to the leach field. And our approved leach field was 500 feet away from our septic tank. And so you have to have a pump that can handle pushing liquids that distance. So we're starting work on our foundation drain, and it's fairly typical to run these with a blanket material that goes underneath and then flips up over with a media of gravel. I'm trying something that the county said should be fine. It's a little different. So this is a drain sleeve, and they said that they should be fine with that. It's going to basically mean a lot less imported material for me and a reduction in cost. I don't really have any concerns about the foundation drain not being able to get the water down to it. It's not super deep, and where it is deep, the soil is fairly well draining. This triple wall HD PE perf pipe that I'm using for the drain, it's 4-inch. It goes fine over the like that, the connections, but it doesn't go so well over the pipe itself. So I'm attempting to glue this and then hold it for a minute and then slide this sleeve up and over and get it to go around these corners that way. So I'm standing in our septic pressure pipe that goes from that way uphill, around the corner, a whole bunch of distance traveled, and eventually dead ends in our septic drain field. And we are right here at the shop, and we're going to be adding in the shop into the house's septic system. So we're also taking a drain down from the shop in this same trench, headed this way forwards, and then down the hill to where it will meet in with the house's septic below the house. So we have a nice, great big space to work with here. And we're also putting water in. So what we're gonna do is we're just gonna have the pressure pipe, which is the white stuff here, hugged close but not touching with the 3-inch black pipe, which is our shop's drain down to the tank on the left side. And then the water is gonna come over here on the right side. They can be in the same trench, and as they are all materials that are modern and usable in a house according to code, I don't have to have it necessarily up on a shelf or anything like that. Got the pipe down all the way to the corner of the house. Quite a distance it's got to go from the bottom of the house septic tank up to the shop. Basically follows this trench up here, up, over. We haven't hooked it into the shop yet. We're gonna wait until we're basically ready to call for an inspection, and then do that with the shortest time in between possible, because we do use it for hand washing and stuff even now. Every 100 feet or less, or 135-degree change in direction, requires a standpipe. So there's going to be a standpipe right there. There'll be one here, and then it's going to come down, comes around this corner here where I'm standing, goes all the way down the hill, and then right here it cuts across, goes that way to join in with the house line. And so there's going to be a stand clean out right in there before it turns. So we are working on getting the conduit laid and pulled and set up so that we can get power from our shutoff main down to our house. If I can get it down there, I can go ahead and get the panel installed. We can get a breaker and a plug or two in there. It'd be a lot easier than having to run a jumper all the way down the hill all the time. This is a heavy gauge of wire that we have here. So to run 200 amp that distance through conduit, the only thing that I could find locally available, because there's been just a continuing shortage for a long time, was this guy. And I could direct bury him, but I'd have to go deeper, and also just wanted the extra security of knowing that it was in conduit. So you can see that the sweep is 3-inch, and that's a different size pipe. So we did reduce and go down to 2.5-inch. I was able to find some 2.5-inch that somebody had used for part of a project and then decided to go a different way. And so we had a good price on all this. And it's funny as far as fittings go, and a little finicky to find the right fittings in the local big box stores, but aside from that, it saved me a bunch of money. So that's why. Basically, we've got the end of the wire down there, and we've been pulling the conduit on and gluing it as we go, and that's worked okay. It's a pain, but definitely wouldn't have gone any other way for the size of aluminum quadruple wire, which is what this is. Work our way down here, pull this sleeve through and get around down through the corner that's down in here, and then it should pull smoothly pretty much down to the next step just fine. We do need to give plenty of time for our glue to hold. 30 seconds. I'm doing a lot more than that. I'm doing more like a minute. So as I'm coming down these edges here, my theory is that the water is going to be coming down, hitting this side here as it drops. And I could use, and I should probably use, a solid pipe, not the perf for this. But I do like the idea of it being able to take water in through this pipe all the way through. And so I am running it vertical. And my idea is that it's gonna, any water coming down this pipe is gonna slide on this side, given that's right here and that's the way the angle is. So that's why I'm facing it away from where the slope of the soil is. Anything that's further up in the trench should have already caught and gotten into the pipe if it's going to, and if not, it's going to run down next to the pipe anyway, and then we'll catch it on the bottom when we get to the next section of the perf on the horizontal. We want this to stand as vertical as we can get it. We can go ahead and glue this guy, because I can easily get it around both corners without the sleeve on. I was hoping to maintain that sleeve because this is a 100-foot pipe. We've only gone like 20, so I definitely went the wrong way with this, but it'll be just fine. I'm gonna go ahead and just use a nice helping of glue on all these joints. Now, one thing I am doing is, you can see right where the cast mark from the couplings, that is my delineation, and in order to have the holes on their bottom where they're supposed to be at angles out to both sides, that's where the perf pipe is supposed to take water up into it. It's not supposed to be on the top. In order to get that, you just line your printed lettering, which is basically that is the top, and you just line that up with, you know, the cast mark on your coupler. So we chose perforated pipe for our around the house drain system. We did not choose corrugated pipe, and typically in our area, there's very few applications of our municipality, which is the county, based off of state recs, really likes to see corrugated pipe, which is the typically black pipe that has the ridges, and then it also has perforations or holes. So we worked with our county to understand exactly what they're looking for, given that the code is not as closely regulated for us as other things like sewage are. And there's a lot of different ways that you can do this job of putting in a curtain or foundation drain, well, the whole foundation of your house. Once you get down here, you still have to maintain your slope. And so that is the one thing I'm worried about down here. Just looking at this footing and knowing what I know about this foundation, I might not have the sufficient slope as you come this way up until about there, and then it should peter back off down the hill. But I'm going to check that and make sure we're good to go. Behind me here we have the point at which our house's sewer exits the house and goes down the hill to our septic system. So I chose to have our sewer line a 4-inch line exiting the house. There's code that stipulates exactly how many fixtures can be connected into your sewer line before it has to be upsized to 4-inch from 3. And we actually hit that slightly. We're just off of hitting that. 35 DFU is the max, and we were slightly off of that. But in case we ever wanted to add anything in, I went ahead and used 4. And we just got this corner piece in right below me here. So this part is just the septic, and we didn't feel like we needed to rent a vehicle or equipment, heavy equipment to get this done. So we've just cut this by hand from where I am past Casey over to the other side. It's about 40 feet, so not too bad. Not very deep either, because we're going to be putting fill on top of this. The level's coming up. We're just making sure that the spirit shows that we're where we should be as far as level goes, which we are so far. So the septic interchange down here is done. This is the line that comes down from the house down to the septic tank. Coming up, you can see we've got the required parts and pieces, clean out on the outside. This is all on 4-inch. Had a chunk left over a 4-inch here, so I went ahead and brought it out and then did my reducer. So then I was able to use 2 little scrap pieces because I'm cheap and couplers are cheaper than pipe. And then we got our corner just in. That's the last part that I did, which I chose to do that last because that let me do exactly what I have here, which is force this to go in together and hold together. We did use the correct glue to make sure that the ABS joined properly with the PVC. So pouring down sweat out here because I am working on the underground utilities today, and I've got the electrical conduit line all pulled through, and right now I'm just working on getting ready to feed it through the sweep that runs through the concrete. I'm dripping on my face here. Right now I'm getting ready to run it up through the stem wall conduit sweep, which is 3-inch, so I just upsized through complicated fittings because of course we don't have a 3 reducer or 2.5 to 3. Go figure, anywhere near, and I don't want to wait. So I just got a 3 to 2 and a 2.5. So here's the entry to the building. Comes up, goes inside, and we're actually going to probably be pulling it in, over, and down and around to get to the interior laundry room wall and run the main breaker. And essentially what we've done is we've just brought this down, and I've got the last little parts and pieces looped onto the loop. And then I'm going to keep feeding it through until it gets down to the end. I'll glue them all up and shove them down together. And I better have got this pipe's length right, because otherwise it's going to be real unfortunate to try and get that all back out. So we've got this line in all the way down the house. We are now working on the rain drain, which is this one. That's the foundation drain. And you can see here we have a sleeve on that's not going anywhere yet. We're going to run this down as far as it goes that way after running it around the corner and around that corner to meet up with the other side, because we haven't joined in down there at the very corner yet. And we'll do that once we know whether this is enough sleeve or if we have to get one more roll, and then that way we can slide one on from that end if we need to. But that's all solidifying. I'm letting it harden out really nice before I do anything more with it. So why do we choose this pipe? So we chose just the basic white perf pipe because it's not going to be subject to any extreme forces. It's a different type of plasticized pipe than PVC, which is also commonly used for this type of drainage or for rain drains. And the cost difference is about twice as much. So given that it's not going to be subjected to crushing pressure, it's not going anywhere where it would be driven over, and given that our soil is not super heavy clay, and it does drain fairly well, we decided to go ahead and use this pipe. We have one rain drain downspout coming off of the lower deck roof, one immediately adjacent to it coming off of the upper roof, and then one coming off of the first roof section, the 1-story only section of the house. And up here, it's going to connect in from the upper roof way up here. It's going to connect in and go onto that roof and then come down into that downspout. Now I could have put an additional one all the way down right there, and I would have had to if I'd done 3-inch instead of 4. So this saves us on cost of guttering and gutter materials, but doesn't really impact the cost of the total system. You are correct. That is a sanitary tee in a rain drain. The inspector said that it is fine in our area. The moment that at least we've been waiting for with great anticipation. Our septic line down from the shop is approved. Our septic pump system and the pump line and the leach field are all approved. We are good for burial, and right now I can do this. And now we can use whatever facilities we want. Where the water enters either the shop or the house, split. To the right there is where it enters the shop, and to the left is where it goes down to the house. And it just kind of goes around the shop building this way and heads up to the well house from there. We have it in our trench along with our effluent and our sewage from the shop down. Just travels over, goes down. And unlike the sewage, the setback isn't so much that we couldn't put it next to the house over here. So it comes down, leaves the trench with the power, goes over to about there on the house, and then enters. And our water is just a 1-inch line. And your supply to your house might be anything from 1 inch to 3/4. Those are typical. If it's less than that, then you're probably not going to end up being able to run a lot of fixtures at one time. 1/2 inch has occasionally happened for some people, especially in older homes. But 1 inch makes it to where you can run garden hoses off the side of your house, do the dishes, run some laundry, much more convenient. What we ended up doing is we took that joint there, propped it way up back that way, and then fed it downwards, and then she pulled from the inside, and I pushed the wire up into that loop that goes up into the stem wall. I was able to cinch that down, and it was close enough that I was able to get that to go in and just kind of slide it on. So over there is where we join into the building, and the trench comes at a relatively straight, flat rate here, slightly going uphill, and then hits this point where we suddenly jog and we go up the hill. And I ended up using these 2 45s to kind of bump that and go up the hill. And honestly, they were more of a pain in the backside than I expected they would be. So I think that the reason they were such a pain was because we definitely sized the conduit to the the very most we could possibly pull that wire through. Those were, with it being aluminum wires and with it being aluminum wires that were able to be used in conduit or in ground, very versatile. However, also they were very thick. And so those 45s behind me on that steep part of the slope right there, they really kind of caused us some problems. Okay, let's see how much that is. So our in-ground utilities, electrical and water, have also been approved now. We are good to go. We are able to cover everything we have. Water is down to the house. It's under pressure and no leaks. And electrical is down to the house. And we actually ended up with a fair amount of extra wire. And it's not cheap, you know, per foot. There's, I think I got it $7 a foot or something like that. Um, Might have been a lot more than that. I could honestly be misremembering. So our utilities journey, a couple of key learnings for this end step where, you know, we're past kind of the point where it's an outside company, but it's our trenching, our wire, our conduit, our pipe that I wanted to share with you guys. So the first key learning I would say is that if you can run everything in a shared trench, you should, and you should have your excavator, or if you're doing it yourself, cut a 2-foot wide trench. There's individual spacings or setbacks that each type of utility has to have from other utilities, and there's also depth that's a minimum depth that each of the types of utility has to have. So electrical in our area is minimum of 18 inches, water main is minimum of 2 feet, and then septic coming down the hill, you can actually bury very shallowly here. You probably noticed in earlier videos that pipe has been sitting there unglued for some time. So I initially thought that we'd be further along much faster with the utilities, and that just didn't happen. So the utilities have dragged on and on and on, and that's why this video you'll see a lot of movement and a lot of changes in the house because we've been working on the utilities when we can, when it makes sense, and then working on the house the rest of the time. So the pipe was dry fit, and I cut that, and I didn't have any problems just letting it sit there. But I like to dry fit as much as I can, because while you won't get the pipe to cinch the last, you know, little bit into each of the couplers until you glue it, which provides, you know, reduces the friction, it gives you the ability to get basically a complete system accurately cut, and then you can assemble it. And if you work piece by piece and glue and cut and glue and cut and glue, you really have to know what you're doing better than I do. It's just, otherwise you're gonna end up having to cut stuff out and redo it. One thing I wanted to share in my experience of running this conduit is that if I had it to do again, my excavator had asked, as he was kind of going downhill, You know, do you want me to step this kind of to match the terrain and then you can use 45s, or do you want me to cut it super deep? And I figured it was probably better to not cut it super deep and to kind of step it to match the hill. And I wish I had said the other way. So when you plan out your utilities, check with your building department, make sure that you have, you know, exactly what they want. I'll give you some examples of stuff that I hadn't realized that they would want, that if I just had known in advance, I might have planned differently and done a single trench. So first, water and electrical conduit, actually, water main and electrical conduit, they wanted to have 1 foot of separation. And the septic line and the water main, they also wanted to have 1 foot of separation. So, you know, you kind of have to plan where everything is going in the trench, and then those are going different places. You know, if they're in a shared trench, they're going different places, and so they are going to be crossing each other. One of the other things that I didn't realize is that even if you're allowed to put things next to each other, they don't want them right against each other, because there's a concern that there might be a friction of the two pipes moving against each other, I guess, and could wear on them over time. And so they want you to have some separation. I'll give you an example. So we had our pressure effluent coming from the septic tank up to our leach field in the same trench on the same side as our septic. Gravity flow from our shop headed down around the house to our septic tank, but they still wanted them to be not touching and separate the whole way down. And so all these things take up a lot of space, so you want to have a big trench. Another key learning for us, have the right size of conduit for your pipe. And if 2.5 is good, then 3 inches is going to be great. This doesn't look like it's filling that up all that much, but to be honest, I wish I'd had more room. It would have been a lot easier to pull. The cost of this pipe comparatively, it's much cheaper than the PVC is at this time for us, and that's the primary driver of us choosing to use it. As far as obviously we're also using a sleeve. The media for a French drain, that rock, would have added substantial cost versus simply putting the native soil back on top, and we just didn't feel like there was justification for it. So the rain drains are the same. Rain drains are also in that same pipe. It's just the non-perforated version, and it saved us literally hundreds of dollars. I could actually have gotten away with a 3-inch pipe for our rain drains. I ended up choosing to go with a 4-inch rain drain system and fewer actual downspouts. And you have to basically reference the code, reference your annual area rainfall, and it also will show you where your area is heavy as an individual event. You have to go online or go to your municipality and find that information. Once you have that, then you can determine how many downspouts for the area of your roof you need and what size of pipe you're going to need.